All right, welcome to the keynote session. Um, the topic of this keynote is embracing reproducibility in spatial data analysis. My name is Kamarul Imran Musa, and I'm from the School of Medical Sciences, University Science Malaysia, Malaysia. So first, we go to the definitions and types. Reproducibility means the ability to duplicate results. And replicability means the ability to duplicate results, but to new data. And there are different types of reproducibility. First, you have methods reproducibility, and you have results reproducibility, and you have inferential reproducibility. Methods reproducibility means the ability to implement the experimental procedures, using the same data and tools and obtain the same results. In result reproducibility, it means that the productions of corroborating results in new study having followed the same experimental methods. Okay, and inferential reproducibility is making of knowledge claims of similar strengths from study replications or reanalysis. Replicability also means that different teams, but with the same experimental setup, can obtain similar findings with stated precision. And the criteria for these experiments include you do same measurement procedure, you do same measuring system, you do under the same operating conditions, and you can do it in the same or at different locations on multiple trials. And for computational experiments with computers, that means that there is an independent group that will obtain the same result using the author's own artifacts. The motivation for this talk is because of this reproducibility crisis. Reproducible and replication crises are real. And in fact, it was published in Nature, a survey published in 2018, where participant was asked, is there a reproducibility crisis? And 52% said yes, a significant crisis. So because of this, the reproducibility and replicability crisis must be addressed. We have also noted that some higher profile studies with problems with reproducibility, and the scientific community is becoming more open, open data which promote sharing and collaboration, that you need to ensure everyone works on the same page. And the movement from close peer review to more open review. And there is also an issue with big data, because big data has problems with representativeness, biases, and veracity. And to handle this, you need to have open and reproducible methods. So the aims of the keynote is, number one, to define reproducibility and replicability. I've done that. And to understand the role of reproducibility and replicability, partly I've mentioned that. And to identify challenges when ones need to embrace reproducibility in spatial data analysis. If you look at spatial data analysis, it is special because spatial data requires extra skills. And why it requires extra skills? Because spatial data are geo-referenced. Because of that, it requires more assumptions for analysis. These assumptions or the manipulations include some features of spatial information. For example, you have projections, you have different file format, and we have to also acknowledge there are well-known software for spatial data analysis, commercial software. Unfortunately, most of them, if not all, are in closed form. And we have noticed that researchers are moving away from the closed form software to more open form software that are driven by the community. We have also noticed that users and analysts are engaging in more hands-on and high-level programming. There has been evidence of increasing use of Python, TCL, Ruby, and R in spatial data analysis. And how to incorporate reproducibility in spatial data analysis? First, we have to think what we need to do before the analysis itself takes place. We have to ask ourselves, is that spatial data analyzable in reproducible manners? So because of that, we must consider the storage of the spatial data, the transfer of the data, in the format of the data themselves. We have to also look at the people before the analysis. Are there experts available? Are there trainers? Are people trained? Because we need skills for reproducibility. And in fact, in the same publication that I mentioned before, when participants was asked, have you established procedure for reproducibility? Unfortunately, 34% responded no. And when we want to incorporate reproducibility in spatial data analysis, we have to look at the tools. We have to choose suitable tools. Okay. Some of the features that you might want to consider include tools that promote sharing, tools that are flexible, tools that are powerful, and tools that make use of open source environment. For example, Python software with GIS capability, R software with GIS capability, notebook tools like Jupyter and R Markdown. So R Studio, that is the IDE for R. Python libraries for Pythons are two good candidates for this, for the tools to conduct spatial data analysis. We can also assess, how good the reproducibility for GIS. We can look at the data section, the method section, and the results section. In fact, this was published recently in PAJ where the authors have proposed this criteria. You have to ask that if there are evidences for reproducibility for the data, for the methods, for the results. And if they are not available, you give 0 marks. And if they are documented and you can recreate reproducibility, then give 1. If they are available but it uses non-public licenses, you can give 2 marks. And if they are available, uses open source and permanent, you can give 3 marks. One software that is close to my heart is R. R is a very good tool for spatial data analysis. R has this innovative analytical and visual approaches. It discourages black box analysis. It is open source, of course, so all aspects of the software tools can be subject to scrutiny. The packages are open source too. You can go to the CRAN website. The website stores the packages for our software. It is open for everyone, so the codes are visible and the community can contribute to the development of the package. For the R software, one of the most popular GUI or graphical user interface or IDE, the integrated desktop environment for R is RStudio. RStudio. RStudio provides environment for open practices. It has the Markdown editor, which it calls as R Markdown. So with R Markdown, you can easily embed the codes inside the document. You can embed the output, and you can embed data in the document for the analysis. And RStudio promotes tidy data, so you will spend less time cleaning data. And the codes are available either in Swift or in Markdown in the form of R Markdown. So R Markdown promote the analysis of your data properly, promote the sharing of your data, the codes and outputs, and promote the reproducibility analysis of your data. It promotes or it turns the analysis into high quality documents and also reports and also presentations and also dashboards. RStudio, promote sharing of codes and outputs through RPubs. You can publish your results there to GitHub, which you can easily connect with RStudio, and RStudio Connect, which is a commercial software to share the outputs of your analysis. You can even write book using the Bookdown package to share your books generated directly from R. So this is the RStudio interface, and this is the RStudio Connect, which is the publishing component of RStudio. If we look at the spatial data analysis packages in R, you can go to CRAN website and you can look at CRAN task view. There are 2 task views. The first one is the analysis of spatial data and handling and analyzing spatial temporal data. The task view for analysis of spatial data is maintained by Roger Vivan. Inside this, you can find a number of packages that are very powerful, very useful to analyze spatial data. And at the PEBSMA is the maintainer for the handling and analyzing spatial temporal data task view, and inside there you will see many packages that can handle and analyze spatial temporal data. One of the most recent development of R package to handle spatial data is the SF package. This is the vignette of the SF package for R. SF stands for simple features, and SF package describes how objects in the real world are represented in computers. It is defined by OpenGIS Abstract, and it has spatial and non-spatial attributes. And spatial attributes are geometry valued, and simple features are based on 2D geometry with linear interpolation between vertices. I highly encourage you to go to this website to look at the vignette of simple feature package. We have to also acknowledge the challenges to embrace reproducibility. And number one, the people. People need to give commitment for reproducibility. Number two, there are peer pressure that can discourage people from using open source software that promote reproducibility. Management pressures into using existing software. No or absent or lack of skills to code if you are using R or Python. No clear or workable spatial data analysis workflow that promote reproducibility, and resistance for OpenGIS tools that promotes reproducibility. So these are the challenges that you have to look if you want to promote reproducibility in your organization. Also look at the technology and tools challenges. For example, technology in spatial data analysis changes very quickly. There are competitions from other closed form GIS software. They are becoming cheaper and cheaper. And if you are using open source GIS software, people have to maintain them. All right? And funding, because these are open source software, the sources of fundings might be more limited. And in addition to that, you have to get extra fund to train your people. You have to develop new infrastructure for spatial data analysis to suit reproducibility. And sometimes open source spatial data analysis tools are too flexible, and it confuses new users, unlike the point and click software that is always the same over the years. There are also challenges in the form of data, because data or spatial data get more complicated. Spatial data gets larger. Spatial data gets more complex. And there is also ecology fallacy. Ecology fallacy happens if you analyze aggregated spatial data rather than the individual patients or participants' spatial data. So be careful if you analyzed aggregated data, not the individual participant or patient's data. In summary, we are facing a real reproducibility and replicability crisis. It's, it has happened and it's happening now. And we also observe more complicated spatial data that becomes major challenges to spatial data analysts. However, we also acknowledge that there are increasing demands for reproducibility and replicability in spatial data analysis, which means we need to equip people with the right skills. We need to provide better tools for them to perform reproducible spatial data analysis. And we have to gather better quality data. We must also acknowledge challenges, the people factors, the tools factors, and the data factors when we want to advocate reproducibility in our organization. Um, but we have to realize that spatial data analysts must practice reproducibility, and it must happen now. Um, that's is basically the keynote from me. If you have questions, then um, you can email them to me. And this is my email, drkamarul@usm.my, and this is my Twitter handle. And this is our lovely medical school, School of Medical Sciences, Health Campus, University Science, Malaysia. And these are the list of some of the references that I've used for these presentations. With that, I thank you for your kind attention. Stay safe and have a nice day.